in the US. So if we build these ecosystems now, we can leapfrog them, and 10 years, 20 years from now, we can have that human resource who's excited about space, who started learning about it when they were in 5th class, and they already built a Bellatrix Aerospace by the time they got into college and did not have to wait as long as Rohan. Okay, so that's the vision with which we are doing this, and that was just a little bit about my journey. Yeah.
Any plans of making L-class or M-class motors?
Yeah?
Any plans of building L-class and M-class motors?
M-class and L-class. So, the next propellant that we are going to move on to is APCP. This is ammonium perchlorate composite propellant. So, we always select propellants which do not degrade over time. Most propellants which are of higher performance, the problem that they have is that they degrade over time and they cannot be stored. And since we look at it this from a very, very commercial perspective, we look at it from that perspective. So that's why the next propellant that we'll be using is APCP. M-class and L-class are possible within APCP, but I don't really see a market in India. So even in the US, an M-class motor costs approximately 90,000 Indian rupees. This is one motor for one flight without the rocket. And obviously if you're using a motor of that size, you are looking to build a rocket that can actually take that and has an experimental value enough that you would want to spend that kind of money. So in India, I've seen that we tend to be a little more hands-on when it comes to spending money. So if there is anybody who would have a budget where they would actually be ready to deploy 90,000 rupees to a propulsion system, then I would actually recommend them to build their own. And they can learn using our smaller and cheaper propulsion systems on how to do that. And our perspective in this whole thing is that we will enable them with components. So we will enable you with that box which you need, that carbon fiber casing, that nozzle which is designed to your CDL ratios, that throat area that you want. It can be customized and it can be low cost. So me providing you that casing, me providing you an insight into how to ignite it, what are the igniters available in the market, standard, off the shelf, making them available to you. That would cost less than 15,000, 20,000 rupees to you, and you can sort of build your own thing, get much more insight. So that's our perspective of the whole thing. So ideally, commercially, we will be enabling B, C, D, E and F. That's the plan for the next 2-3 years as of now. We would have a wide range in all of these categories in terms of what kind of application you are looking for. Are you just looking to go high? Are you looking to stay at a certain height for a longer period of time, so maybe have some horizontal velocity? Are you looking to deploy a payload? Are you looking at multi-stage rockets? Are you looking at stuff like that? We would sort of vary and sort of create categories within our range, which we are sort of doing right now. We plan to release, so we've already released 3 of these to the market. We plan to expand this range to more than 30 different motors by the end of, say, March. And so these things come out in batches, so we release them commercially at one go. So that's the sort of the plan for now.
Bro, like there are a lot of restrictions for drones, right? So what are the restrictions that you face when the rocket?
So that is the question, isn't it? So regulation. So regulation for rocketry is a two-sided story. One side is building the thing, transporting it, storing it, and so on. The second side is flying it. So building the thing is a problem because you're using fuel which is explosive in nature, and our propellant is not water, so we can't drink it to hide it. So that has its own set of regulations in place by the Indian government already. So either you can comply to those rules, or you can operate as an educational institute or a research facility, which shall have at any given point of time less than 5 kilograms of said explosive. So for that, there's a standard format existent. The problem with that format for an entrepreneur or a young startup is that it is highly capital intensive, and that sort of makes it a restricted space. So The law was designed in 1886. The Explosives Act is actually 1886. Again, not 1986. 1886 is more than 100 years old. So it was basically a law designed by British to keep Indian businessmen out of the business of explosives. And we still have that same law. So it's a really restrictive law. But then at the same time, things are changing. The government is receptive. We have had a lot of conversations with DIPP around this, and they even introduced a new licensing category which sort of removes one of these barriers, which is product definition. So earlier in Explosives Act, you had to define your product always and tell the department exactly what you will be making. And only then you would sort of get the permission. But now they've introduced these new licensing regimes where you can tell them what explosives you're using and your general application area, and you don't need to define your product to specification level value. So that's one solution that the government has sort of introduced. On the flying side of it, something beautiful that happened for us is drone law. So drone regulations came into place, and they defined nano drones as a category of drones for which you don't need permission to fly. This category basically means that you have, if your drone is below 1.5 kilograms, if it is flying below 1100 feet, and if the total possible flight time of the drone at a fully charged battery or a fully fueled propulsion system is less than 15 minutes, then you can fly this drone in an interior of a building or even in a ground outside without any sort of permissions from anybody, unless and until you are flying in a restricted airspace, which will be areas in and around airports, in and around defense installations, in and around buildings of national security, in and around heritage monuments. So heritage monuments, our wedding photographers have taken heed to, so they're like, they don't care about that. But otherwise, that law exists. So even though we are not a drone, and per se we should not be qualified or classified under that category, but what happens is that our rockets are below 1.5 kilograms, they are below 1000 feet, and they definitely do not have a flight time of 15 minutes. So using that sort of loophole definition, we have enabled our customers to fly without permission anywhere across the country until and unless they are not flying in a restricted airspace.
All these rockets you build, are they reusable?
So yeah, they land with a parachute, and you can just refill fuel and you can launch them again. Rather, the bigger ones now that we are launching with our D-class motor, you will be able to put instrumentation on them. So we've already experimented with altimeters and pressure sensors, but now with the D-class motor, you will be able to put a complete CANSAT sensor package. So you can put an accelerometer, you can put a gyro, you can put altimeter, pressure sensor, moisture sensor, you can put a camera, but not a GoPro style camera, it's a smaller VGA camera. So all of this instrumentation and any other ideas that you can get, you can sort of execute. So a very interesting project that's actually happening in one of our labs in Telangana. It's a school lab, by the way. This is a project being run by 8th class students and their teacher over there, where they have a bunch of C-class motors, and they've built one of our rockets. It's actually they built a fleet of 4 of them. And they have one altimeter package with them. One pressure sensor package with it. It doesn't have altimeter, it's a pressure sensor package with them that we provided, that they just fix onto the rocket. And they fly this rocket every day at 5 o'clock for 3 months continuously. What that does is that it gives them the data of that pressure profile in that area at 5 o'clock for 90 days. So this is some sort of data that students can then start understanding and analyzing and looking. And these are young students who have not had exposure to even terms like machine learning. And for them, if I go and tell them that, okay, you can analyze data and you can do this, you can do a Monte Carlo analysis, they will not understand. It will be too dry for them, it will be too detached for them. So this way they can see, this is Excel sheet, there are numbers. If I manipulate these numbers and do these mathematical operations, this will happen, and this gives me this graph, which means this. So it starts becoming real for them, and shows them all 3 aspects of space technology, where once they built a system, then they launched it, deployed it, got the data, analyzed it, and created an application. So that's the full cycle of a space technology system, and it shows them the whole thing. So everyone, please, if you are here in the hall, be seated. Otherwise, can you please move out? It's difficult to sort of run the dialogue over here. Yeah. Any more questions? Yes. Yeah.
So, Divanshu, you also, sent out a message that, see, when I was a student, hobby into RC plane flying was a very costly affair.
Yeah.
Yeah? And people think rocket is even more costlier.
Yeah.
So they don't even look at it. Right? But what you're trying to do is that kit costs much, much, much less than try to build an RC aeroplane. It's much cool to do rockets.
Yeah.
So how did you manage to bring down the cost of these rockets lower than that of RC aeroplanes?
So we built our own manufacturing systems. Everything that we are making, none of it is made on standard machines. All the machines that we are using have been built by us from scratch. I have literally gone to welder shops, told him to weld, and when I don't like his work, I told him to move aside and welded the part myself or run the lathe myself to sort of do that lower cost. Another example is that we are very, very lean. So I keep the warehouse of Rocketeers in Ludhiana because I don't have to pay rent. My father's factory is over there. I can just use that. So like we try to keep, like our team is still just 3 people and 4, like we have a moving position. So the idea for us is to sort of enable this at as low cost as possible. So we sort of have that in our mind at every step of the way. And we sort of look at how we can lower costs for ourselves as a core metric for that, because the lower the cost for us, the lower the cost for the customer. And this includes overheads as well.
Rocketry, right?
Yeah.
So center of gravity, center of pressure, how
Yeah.
do you do it? So it's a very good learning platform. So when I went to the US, I got this Estes model rocketry kit.
Yeah.
Yeah?
Yeah.
But that each,
I've flown various Estes rockets.
each cartridge, just to refly it again, cost me so much that that hobby was lost. So can you tell me what is the cost of your cartridge to refill and fly it again?
So against an Estes cartridge, which is currently at about $11 for a C65, we give that same C65. It's the same cartridge, same size, same specification, same thrust. We are actually getting better specific impulse. So that cartridge is for 200 rupees plus GST. Yeah, GST is very important. See, GST is very important. Indian companies have to give GST to launch satellites. What are you talking about? Okay. So, yeah. Do you want? Yeah. Yeah. So that's where we sort of come in. If you take, say for example, this is the first time you're doing it. Up till now you don't know anything. So first time we would recommend you buy a complete kit. And since we've made it accessible, you like a lot of ways that you can afford to do that. You participate in 5 college fests, you win enough prize money to afford 2 kits. So from that perspective, once you get the full kit, that has everything you need. It has a set of instructions. It has an ignition system which will put you in a safe distance. The propulsion system is designed to be safe. So the first time you're flying it, if you're using basic common sense, and if you're not flying it inside a building and you're going out to a ground which is big enough, and stuff like that, if you're using basic common sense, you'll be safe. So see, we have done a lot of things on our end to sort of make sure that even misuse does not lead to personal harm. It may lead to property destruction, but it doesn't lead to personal harm. So for example, even in case of propellant malfunction, where our core design or our grain design has say malfunctioned in one of the propulsion casings and the thing just explodes. Our fuel cartridge casing has a safety factor of 3x. So the peak pressures that fuel can create, even burning in 0.01 seconds, the complete fuel, those pressures, the casing can handle almost 2.2 times of that. So it won't, the casing itself will contain the explosion. Another sort of failure mode that happens is that you have nozzle failures where your nozzle sort of pops out of the propulsion system, and that may directly hurt people. So for that, we have our launch pad that we have designed. It has a whole pathway. In case that nozzle failure happens, that nozzle gets contained within that pathway on the launch pad. So these are some sort of basic safety precautions you can say that we have taken, and we have designed the whole system to be highly intuitive and very common sense driven. So unless and until someone really just intends to misuse it, without intention accidents will not really hurt people. Another thing that comes up a lot, especially when I'm discussing with regulators or principals or people who are in decision-making positions regarding this at an institutional level, they say that what if a student takes 5 or 6 or 10 of your fuel cartridges and takes out fuel from all of them and does something. So we have designed our fuel to be highly hygroscopic, and it works only at a certain grain design. So as soon as you take it out of the fuel cartridges, it will crumble into a powder form which is inert by itself. So if you burn it just like that, it will burn slowly, just not doing anything. It will not create energy. If you want to create energy out of it, you have to reprocess it. And if you are going to be reprocessing fuel, you might as well just make your own from scratch. So yeah, anybody else?
No.
Thank you, everyone. Yeah. Hi. How are you?
Okay. It was great, and I hope you enjoyed that talk as well. So, you know, India is one of the only countries in the world which actually started the space program with a civilian space program. Most other countries in the world who started a space program started it with military focus. And one of the things that is a hallmark of the Indian space program is actually international collaboration. So what happened is Vikram Sarabhai, who was the head of the space program, who started the space program, he was collaborating with a French scientist. And how that happened is that this French scientist, he had an Indian student, and this Indian student told this French scientist that you know, Sarabhai is starting the Indian space program. Why don't we collaborate with him and do something in India? And that was in 1961 or something like that, right? And in 1963, the French provided a payload on the first Indian, you know, the Nike Apache rocket that was flown. And since then, India and France have been doing a lot of work together. So today we have my friend Mathiew here. He is a diplomat, and he's also has a long career in space, starting from selling rockets to you know, managing astronauts to now living in India for 6 years, and managing the entire relationship between India and France. So I think anything with respect to Prime Minister Modi and Macron signing something, he's the guy behind all of that. So so I think you know, he can talk about his experience of India. What I thought it will be insightful for him to talk about his experience of dealing with Indians. And I also think that personally he is the only Western person that I know who understands India and Indian space culture the most. I have seen nobody else who has invested himself so much to understand Indian culture and Indian you know, work ethics in the space program as much as he has done. So I'd like to invite him and then take over. Yeah.
Thank you very much, Narayan. I think this works.
Okay.
Okay. So hi, very glad to be here. I'm not sure I deserve all of that, but so I am. I'm French, and we have today a very, very comprehensive cooperation with India in space. It is well, it has been highlighted like 1 week ago or 10 days ago when your Prime Minister went to France to the G7 meeting, and we signed an agreement to build 10 to 12 satellites together for, no, it doesn't work, for maritime surveillance. So we will be the first public constellation that's put into orbit, because usually these constellations are private funded. Here we are on a public funding base between two countries, India and France, and this is only the last of a long series of cooperation. So the fact is that our two countries found a very good ground of understanding, I'd like to say.
Because it's recording.
Okay. Since, what Narayan said, 1963, we are working together, and it never stopped. You know, you can have a partner, but there are events in time that that sometimes you go away from your partner, maybe you come back. This never happened between India and France. So India and France always stayed linked in the space sector, and for more than 55 years we have worked together. And what we are benefiting of now is an enormous level of trust that goes way beyond what we have with other countries. We are sharing information with India in strategic fields that we are not sharing with UK, for example, or other European countries. So you have to imagine that this relationship is more than just a cooperation, or it has become a very strategic relationship. So coming from a space agency, I might be a little different from most of you, because you are the private part and the dynamic startup part, and the people we are all putting a lot of hope into being the next generation and taking over what we guys have done in what you have called old space, and you're right in a way. Well, I would like to say that our role has maybe never been as important on a couple of topics. Like, what we are doing in agencies is that we develop things that industry would not develop because too risky, too expensive. So we are concentrating on first-time technologies, technologies of after tomorrow, very much long-term and visionary things. I mean, what happened yesterday night showed that we are taking risks as space agencies, and it's our role to take risks as space agencies. It's not that the role of the industry is to take commercial risk. It's not the same kind of risk. So the technical risk, it's our business to deal with. And in our company, for example, in our agency, we have a very strict rule that we develop only once a technology. So we will build a new satellite, for example, or a new subsystem, a new instrument. And once it works, we will never do it again. So people come to us and say, but what about continuity of data and so on? That's not our job. Then it has to go to industry, and industry has to take it over and then build it and make continuity and so on. But our job is to open the doors, the technical doors. So that's one side of the coin where I personally think we are still important as old guys and old space. The other side of the coin is that with climate becoming more and more frightening for all of us, and especially for our economies and, let's say, our survival on this planet, space has been identified as the only place from which you can have a global view on climate changes. So there is no other place in the world you could put climate instruments on every little spot on Earth. You would never manage to have a comprehensive view as the one you have from satellites. So that is why, since now 10 years, maybe a little bit more, it has become clear to governments that satellites are absolutely essential for climate understanding. And we have put together, ISRO and CNES, like 5 to 6 years ago, we proposed a meeting in Delhi for all space agencies in the world, which means the big ones. So we had in Delhi the administrator of NASA, the head of JAXA, the Chinese head, all the people who count in space. And we made them sign an agreement, which is called the Delhi Declaration, where we said, this is time now not to look at nations, not to look at individual needs, but it is time to put our strengths together. So we have set the basis of a network of all our national satellites that we have for climate monitoring. And we have pushed to all these people accept to put together all their forces. So this is called the Space Climate Observatory, which is existing now. It was officially launched by, in witness of the French President Macron in Paris during the Le Bourget Air Show, which was in June, so a couple of months ago. And chairman of ISRO could not come, but the scientific secretary was there representing India. And this is, I think, media and the press is not giving importance to that because it's not, of course, it's not a moon landing, it's not a satellite that we launch. It is using what we have, but this is of utmost importance because people have, if you take the Japanese, the Europeans, the US, the Indians, the Russians, take only these, put together all the satellites they have to monitor climate. You have people who do, you will have all the levels of monitoring you can imagine. You will have all the kind of instruments on board. You will have, and if you fuse this, if you make a fusion of this data, you get to extremely important information that will allow the world to better understand what is happening. So in doing this, we have identified, for example, that in the Gulf of Bengal, here at large of India, there are water mixes between cold water, warm water temperatures that have an impact on the climate in Europe. So you can see that everything here is linked at very long distances away. So what I would like to stress is that when this, well, everybody speaks of climate today, but no one spoke of climate when India and France decided to put their forces together and say, we want to build a joint climate satellite. That was 2000, it was launched 2011, it was decided 2008, something like that. So we are at a time frame where the climate question was known, but not really considered. At this time, you had already such a high level of trust between the two countries that the two leaders at the time decided to say, climate must be important, we need a satellite. So we built Megatropics together, which is still in orbit. It's a joint French-Indian satellite. And it's monitoring in 3D the moisture in the atmosphere. So what I mean is that you can make videos of clouds running around in the atmosphere. It's absolutely sensational. With this, we have not only improved climate change studies and research by a factor of I don't know how much, but we have also allowed to forecast monsoon events by 5 days. So that the whole matter of, having people losing all their everything they have because a rainfall in the night destroys everything. Now we can give the information with a sufficient time in advance so that the people can harvest in time. So that's part of the idea I want to highlight today because this is the complementary part between the West and India. You do something together. What we guys are looking at, I mean, my colleagues back there, I'm not speaking of me because I'm almost an Indian, but my colleagues over there, they are looking at, you know, climate change, the high things, the political discussions. How can we confirm that this number which were given by this and this group are right, and so on and so on. But that's what the Western people do. What do the Indian people do? The Indian people look at it in a very pragmatic way and say, this thing is interesting for climate change, okay, we do that as well. But we could do more with this thing. We could help our farmers with this thing. We could do, and this is where we in the West have to learn from you in India. Because our minds and our people are not formed in a way to be pragmatic enough. So I will tell you another story. Some time ago, I was the French negotiator in the European Union in Brussels. And they asked me to study how we could help, again, farmers with satellite data. So we had the most important, the brightest brains of Europe around table for weeks and weeks, and they ended up with a report. And the conclusion was every farmer needs to invest 10,000 euros to buy a kind of a receiver with a color screen and satellite reception and wonderful. He can get all the information real time from the satellite down to his tractor. So when I got this, I had to present this to the minister. I told him, sir, this is bullshit. We can immediately put it in the can. There's nothing to expect from this. This is the biggest brains in Europe coming up with a conclusion which is bullshit, which is technically viable, but which is bullshit. Then he said, okay, Mathiew, forget about it. We'll do, just continue doing your best. Okay. So then I came to arrive to India 10 years after that. And I live in Yelahanka. And in some friend of mine said, oh, you're in Yelahanka, you need to visit, there is an agricultural center close to here, it's very nice, and they work with space. So he had a friend, and I could meet his friend, and so we went there. And these guys, I was just bluffed. These guys are doing what I was intended to do, but they do it in a completely different way. So farmers in the field have a phone which is not even a smartphone, a 1,000 rupee phone, just voice. They call this data center. First time they call, their number is recognized. Oh, new caller. So they ask, what language do you speak? What taluk are you in? What are you planting? When did you put the seeds? How are you watering? What kind of fertilizer are you putting? When do you intend to harvest? What, They ask a lot of questions. Second time you call, your number is recognized. Your language is recognized because it's associated to your number. So your call goes to the person who speaks your language, and your field, your ground appears on the screen, and the satellite data, which is all the free satellites in the world. So you have the Landsats, you have the European